Hello. In this video, we want to find all values at x equals a where the function is discontinuous. So here's the thing. For a function to be continuous, it has to be defined. In other words, we need to figure out what is the domain for all of these. Generally speaking, as long as these functions that we have them defined as just a single expression, whatever the domain is, that's going to be where the function is continuous. And so if it's continuous everywhere, then, or if it's continuous everywhere on its domain, it would be discontinuous where it is not in its domain. Okay, so looking at f of x, we have a rational expression. Notice I can't factor the numerator or denominator, but that doesn't matter. I just want to find what the domain is. To find the domain of a rational function, I take the denominator and set it equal to 0. That means that 2x minus 7 has to equal 0, and solve. Add 7, divide by 2, so x equals 7 halves. Now this is technically what the denominator cannot equal. That's what the domain is. So the domain itself is where x is not equal to 7 halves, because 7 halves is just a vertical asymptote in this case. Or if this factor did cancel with 1 up in the numerator, then that 2x minus 7 would actually produce a hole in the graph at x equals 7 over 2. Either way, it wouldn't be part of the domain. But what that tells me is that this function is discontinuous at x equals 7 halves. Good. Now, looking at g of x, here's the thing. E to the 2x minus 3, well, that's just an exponential function. Exponentials, when graphed, look something like this. Now, that won't be exactly what this graph is going to look like, but it looks something like that. But the point is that look at the graph itself. The graph is continuous everywhere, and the domain is all real numbers. So as long as the exponent is in the real numbers, then that's it, which means that this function is never discontinuous. Yeah, no, I can't spell. Fantastic, because the domain is negative infinity to infinity. It's everything, so there's nothing else that's left. Now for the last one, h of x equals the square root of 5x plus 3. The domain for a square root is where the radicand is greater than or equal to 0, and the radicand is what we call the 5x plus 3. So we take that 5x plus 3 and set it greater than or equal to 0. So to do this, we just subtract 3, divide by 5. So the domain is where x is greater than or equal to negative 3 over 5. That means that this function would be discontinuous at any values less than x is greater than or equal to negative 3 over 5. In other words, x is less than negative 3 over 5. And there you go. Alrighty. Well, that's pretty much it for this. I'm going to go ahead and end it here, and I will see you in the next video. Have fun.